Hello, I hope everyone's doing well. Today we're going to go over factors, prime numbers, and composite numbers. So factors are numbers that can divide into whatever number we're working with or whatever integer we're working with. Two. If we were working with 12, for example, 12 can be divided by 3 to get 4. So that makes 3 and 4 factors of 12, because 12 divided by 3 is 4, and 12 divided by 4 would be 3. So when we look at 12, if I listed out my factors for 12, I've got 1 times 12 is a pair of factors. Then I've got 2 times 6. And I've got 3 times 4 for factors of 12. Just a little bit of glare here. Okay. When I do my factors, if I'm trying to list all the factors for a number, I actually like to list it this way. So I know when I'm factoring out a number, that number times 1 is always going to be a set of factors for that number. So 1 times 12 is my first set of factors for 12. 1's going to be my smallest factor, and 12's going to be my biggest factor. And when I'm looking at factors, I'm looking at whole numbers and not decimals, not fractions. So the smallest factor is going to be 1, because it can't be a decimal, it can't be a fraction. Same thing with the biggest number. So since 1's my smallest and 12's my biggest, that means all my other factors are going to fit in between. Okay, I know 12's divisible by 2, which I already did that, but to reiterate, 12's divisible by 2. 2 times 6 was 12, so 2's going to go next to my 1, and then my next biggest is 6. And then, okay, 1, 2, okay, I know 3 goes into 12, so I put down my 3. And then 3 times 4 is 12, so 3's my third smallest, and 4 is my third biggest. 3 and 4 are next to each other on the number line, so that also tells me I'm done factoring. When I'm trying to write all the factors for a number, I know I'm done if I used my end caps to get me started, and then I get to either the same number, like maybe I had a 3 times 3 or something, or I get to 2 consecutive numbers on the number line. Sometimes when I do this, I have a big gap because I put too much room, but it helps me get all my factors put on the table. Factoring our numbers is really helpful when we're doing something like working with fractions, which I'm going to be doing a few videos on coming up before too long. It can also be helpful when we're working with the different kinds of roots, and just it's helpful to understand what factors are. So let's do another one. If I had 25, I want to find the factors of 25. So I'm actually going to list my factors out. I know 1 times 25 is going to be my biggest and my smallest factors. And then looking at it, thinking about my number line, thinking about my 1 through 10. I know all of these numbers do not go into 25, but having them written out kind of helps me think. So, okay, 1 goes into 25, of course. 2, well, 25 is not even, so 2 doesn't go in. 3. 3 times 8 is 24, and then 3 times 9 is 27, so they don't go into 25. 4 doesn't go into 25, because 2 can't go in. 5 goes into 25, and it's 5 times 5 is 25. Since I got to a number times itself, that means I'm done with all of these other factors. And I've fully factored out 25. 25 only has 3 factors. And we'll do one more. Got 36 here. So if I'm factoring out 36, I'm going to start with 1 and 36. And then thinking 1 through 10, 2 goes into 36 because it's even. 2 goes into 36 18 times. 3 goes into 36. And 3 goes into 36 12 times. 4 goes into 36. And 4 goes in 9 times. 36 doesn't end with a 5 or 0, so 5 doesn't go in. But 6 goes in. And 6 goes in 6 times. So I've finished my factors. 36 has quite a few factors that go with it. We've got 1, 2, 3, 4, 6, 9, 12, 18, 36. So that's a quick rundown of what factors are and how to factor something. Let's look at prime versus composite now. So when we're thinking about prime numbers, prime numbers only have 2 factors. And these factors are 1 and the number itself. So some prime numbers include 2, 3, 5, 7, 11, 13, 17, 19, and 23. And there's more, so I'm just gonna put some dots there because they keep going. As infinite as our numbers are, we have infinite prime numbers. So looking at these, what they all have in common is they only have 2 factors. I don't put 1 here because 1 only has 1 factor. But each of these are only divisible by 1 and the number itself. So 2 can only be divided by 2 or 1. 3 could only be divided by 3 or 1. 5 could be divided by 5 or 1, and that pattern continues. If you notice, most of these are odd numbers. We've only got 1 even number on here because even numbers always have the factor of 2. So other than 2, each even number has at least 3 factors because it'll have 1 itself and 2. But since 2 is 2, it only has 2 and 1 for its factors. And if we look at these some more, we notice most of them are odd numbers, but there are some odd numbers missing. Like, okay, we go 3, 5, 7, and then skip to 11. We're missing 9, and 9 is not a prime number because 9 can be divided by 3. 9 can be divided by 1, it can be divided by 9, and it can be divided by 3. So it has 3 factors. That just takes it out of being a prime number. But then what are the numbers that aren't prime numbers? So if it's not a prime number, it's going to be a composite number. And composite numbers have more than 2 factors. So our composite numbers are numbers like 4, 9, 15, 25. And these are just, there's so many. I'm just listing them at random. But they all have more than 2 factors. Like 4's got 1, 4, and 2. 9's got 1, 9, and 3. 15's got 1, 15, 3, and 5. So when we think about if it's not a prime number, it's pretty much got to be a composite number, except for 1. So this information will be pretty helpful when we start getting into fraction stuff. I think next week I'm going to start talking about fractions. If anybody has any questions on anything, feel free to email me with those questions, and we might take a break from the plan I've got planned out and work on whatever it is that you've got the question on. Or I might just do a bonus video one week. That's what I'm here for, answering questions and helping y'all succeed. So if you need anything, just let me know. Y'all have a good day.